Hello dear students, good morning. I welcome you once again to Interactive Virtual Class Nagaland. I hope all of you are doing well. Yes students, so in our yesterday's class we have discussed about what is a solution, correct? We have discussed about the properties of solution. We have discussed about the concentration of solutions, correct? We have discussed that there are two components in solution, that is solute and solvent. When the solution contains lesser amount of solute, it is said to be diluted, right? And it is called dilute solution. And when the solution contains large amount of solute, it is said to have high concentration, and they are called as concentrated solutions. So now concentration of solutions, okay? The concentration of a solution is the amount of solute present in a given amount, mass or volume of solution, or the amount of solute dissolved in a given mass or volume amount of solvent, okay? So depending on the amount of solute present in the solution, we can calculate the concentration of solutions. So let us see, how do we calculate concentration of solutions? So concentration of solution is equal to amount of solute divided by amount of solution, or concentration of solution is equal to amount of solute divided by amount of solvent. Okay, so by using this relation we can calculate the concentration of solutions. Now in case of solute dissolved in liquid solvent, taking the example of salt dissolved in water, okay, here the solute is salt, which is solid, and solvent is water, which is liquid. So in case of solid solute dissolved in liquid solvent, we will use this formula, okay? Concentration of solution is equal to mass of solute divided by mass of solution into 100. In case of liquid solute dissolved in the liquid solvent, okay, in the case of liquid solute dissolved in liquid solvent, we will use this formula, that is concentration of solution is equal to volume of solute by volume of solution into 100. So using this relation we can calculate the concentration of solution, okay? So let us solve some examples, okay? A solution contains 40 gram of common salt in 320 gram of water. Calculate the concentration in terms of mass by mass percentage of the solution. So let us see here. We have here mass of solute, that is salt, is equal to 40 gram. Then we have mass of solvent, water, that is equal to 320 gram. Okay, mass of solution we know, okay, is mass of solution will be total of mass of solute plus mass of solvent. So here we have mass of solution is equal to mass of solute by mass of solute divided by mass of solution into 100. So we have mass of solute is 40, mass of solution is 360, and into 100. So if we substitute the value and calculate this, okay, so the concentration in terms of mass by mass percentage of salt in this solution is 11.1%. okay, we have another example here. A solution contains 50 ml of alcohol mixed with 150 ml of water. Calculate the concentration of this solution. So let us see here. We have concentration of solution is given by volume of solute divided by volume of solution. So here volume of solute is given by 50 ml. Okay, volume of solute, that is alcohol, is equal to 50 ml. Volume of solvent, water, is equal to 150 ml. Okay, so volume of solution will be volume of solute plus volume of solvent. If we add them, we will get 200 ml. So let us see. Therefore, concentration of solution will be volume of solute by volume of solution into 100. So we will get 25%. So by using this relation, we can calculate the concentration of the solution. Alright students, we have the first question for today. Please get your rough devices ready. The question is, a solution that contains a large amount of solute is best described as which of the following? Okay, unsaturated, dilute, concentrated, weak. So I'm giving you 15 seconds for this question. Your time starts now. A solution that contains a large amount of solute is best described as which of the following? Okay, we have 4 options, so choose the correct option. Alright students, your time is up, and yes, very good. The correct answer for this question is option C, that is concentrated. When a solution contains large amount of solute, it is said to have high concentration and it is known as concentrated solution. So here the correct answer is option C. Alright students, so here we have pond, right? We have pond. In pond, they consist of different substances like sand, stone, water, correct? So here, let us take this example. Water and soil. What happens when we mix water and soil? Okay? What type of solution or what type of mixture will this be? Yes, students, we have seen that pond is also a mixture of soil and water. Here we have mixture of soil and water. So what type of mixture are these? Okay, this type of mixture are called suspension. Okay, this type of mixture are called suspension. So this is one example. Now if you can recall, we have discussed 3 beakers containing different substances yesterday, right? We have discussed about this one. Beaker containing 50 ml of water and copper sulfate powder. It is known as solution. Today we will discuss about this second beaker. Okay, take a beaker containing 50 ml of water and add 1 spatula full of chalk powder or wheat flour. Okay, so this beaker. Okay, a beaker containing water with wheat flour will be different from a copper sulfate solution, correct? So this is an example of suspension and we will discuss about it today. Okay, but before we proceed further, let us answer one question, or we can come back to this question later. Okay, so here, suspension. Okay, suspension. So a suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Particles of a suspension are visible to the naked eye. Okay, so a suspension is a heterogeneous mixture. We have seen some examples. Let us see the properties of suspension. Okay, so keeping in mind this example, okay, that is mixture of soil and water. This is an example of suspension. So let us see the properties. A suspension is a heterogeneous mixture. The solution, the composition is not uniform throughout. So it is a heterogeneous mixture. Okay. So the particles of a suspension can be seen by naked eyes. Now when you mix soil with water, you will be able to see, or we will be able to see, the particles of soil in the mixture, correct? So the particles of suspension can be seen by naked eyes. Particle size is larger than 100 nanometer in diameter. Another properties of suspension is, okay, when we pass a beam of light, the particles of a suspension scatter a beam of light passing through it and make its path visible. So the particles of suspension can scatter a beam of light passing through it. Let us see here. Now when you mix soil with water, okay, and left it undisturbed for some time, after some time we will see that the soil particles will settle down at the bottom, correct? Yes. So the solute particles settle down when a suspension is left undisturbed. That is, a suspension is unstable. Okay, it is unstable. The particles of the suspension will settle down if it is left undisturbed. Now they can be separated from the mixture by the process of filtration. Okay, so when we mix soil with water, by filtration method we can separate the water and the soil particles. Yes, so the particles of suspension can be separated from the mixture by the process of filtration. So these are the properties of suspension. Okay. Alright students, we have one more question. Please get your rough devices ready. The question is, an unknown sample scatters light and is separated by a filter. The sample is most likely A or N. Okay. Option A is compound, option B is suspension, option C is solution, and option D is element. So students, I'm giving you 30 seconds for this question. Your time starts now. Yes students, an unknown sample scatters light and is separated by a filter. The sample is most likely option A compound, option B suspension, option C solution, option D element. So which of the following option is the correct answer? Alright students, your time is up, and yes, very good. The correct answer here is option B, that is suspension. Suspension, the particles of suspension can scatter light and can be filtered by the process of filtration. So the correct answer here is option B, that is suspension. Okay, students, coming back to the previous question. Okay, the question we have here is, particles of dash can be seen with naked eyes. Okay, so I'm giving you 30 seconds for this question. Your time starts now. Particles of dash can be seen with naked eyes. Option A is colloids, option B is suspension, option C is solution, and option D is none of this. Yes students, so which of the following option is the correct answer? Alright students, your time is up, and yes, again, very good. The correct answer is option B, that is suspension. Alright students, let us proceed. So know this, okay, know this. The solid substance left behind on the filter paper is called residue, and the clear liquid obtained is called filtrate. Okay, so when you do filtration to separate, okay, the particles of suspension, the solid substance which is left on the filter paper is called residue, remember this term, and the clear liquid obtained is called filtrate. Okay. Activity. So we have an activity. This will be your homework. Okay. Find out the suspensions present in your surroundings and note down the solute and solvent particles present in it. Okay, so this will be your homework, the first homework for today. Okay, find out the suspension present in your surroundings and note down the solute and solvent particles present in it. There are so many things present around us, different types of matter, different types of mixture. So what I want you to do is, I want you to find out the suspension present in your surroundings. Okay, and also identify the solute and solvent particles present in the suspension. Alright students, let us proceed. Here we have jelly. Do you know what is jelly? Yes, we all know, right? So we have jelly here, toothpaste, and we have paint, and we have milk. Okay, so what type of mixtures are these? We have discussed about solution, we have discussed about suspension. So can we classify them under solution? No, right? Can we classify them under suspension? No, right? So these are again different types of mixture, and this type of mixture are called colloidal solution. Okay, colloidal solution. So now coming to the third beaker. Okay, take a beaker containing 50 ml of water and add few drops of milk or ink. Okay, so this third beaker we will discuss now. Okay, so this is example of colloidal solution. Alright students, we have another question. Please get your rough devices ready. Okay, the question is, in filtration, what name is used to describe the solid left in the filter paper? Okay, option A is filtrate, option B is residue, option C is distillate, and option D is precipitate. So I'm giving you 30 seconds for this question. Your time starts now. Infiltration. What name is used to describe the solid left in the filter paper? Option A is filtrate, option B is residue, option C is distillate, and option D is precipitate. Yes, students, so which of the following option is the correct answer? Alright students, your time is up, and yes, very good. We have discussed that in filtration, the solid substance left on the filter paper are called residue. So here the correct answer is option B, that is residue. Good students. So colloidal solution, okay, we have seen some examples of colloidal solution. It is like examples include jelly, toothpaste, milk, paint, okay, etc. So what are colloidal solution? Let us see, okay. The particles of a colloid are uniformly spread throughout the solution. Due to the relatively smaller size of particles as compared to that of a suspension, the mixture appears to be homogeneous. But actually, a colloidal solution is a heterogeneous mixture. Okay, so when we look at taking the simple example, that is milk, when we look at the milk, it appears to be homogeneous, correct? But actually it is heterogeneous. So a colloidal solution is a heterogeneous mixture. Okay, examples of colloidal solutions include cloud, gemstone, face cream, milk, ink, blood, jelly, and solutions of synthetic detergents. All these are examples of colloidal solutions. So let us see the properties of colloids. Okay, colloidal solutions are also called as colloids. Okay, so keeping in mind the examples of the colloids, let us see the properties of colloids. So colloids are heterogeneous mixture. Okay, colloids are heterogeneous mixture. Now when we consider milk, okay, the particles of colloids are relatively smaller than the particles of suspension. Okay, so we cannot see the particles of colloid with naked eyes. Okay, this is the second property of colloids. The next property of colloids is colloids are big enough, okay, colloids particles are big enough to scatter a beam of light passing through it and make its path visible. Okay, colloids particles are not big enough to see with our naked eyes, but they are big enough to scatter a beam of light passing through it and make its path visible. Tyndall effect. So what is Tyndall effect? Here we see the colloidal particles scattering beam of light, correct? So colloidal particles can scatter a beam of light. This scattering of beam of light is called Tyndall effect. Okay, so the scattering of beam of light by colloidal particles is known as Tyndall effect. Remember this, okay? The scattering of beam of visible light by colloidal particles is called the Tyndall effect. Alright students, we have another question. Please get your rough devices ready. The question is, which of the following will show the Tyndall effect? Okay. Option A is salt solution. Option B is milk. Option C is copper sulfate solution. Option D is all of the above. So I'm giving you 30 seconds for this question. Your time starts now. Which of the following will show the Tyndall effect? We have just discussed about what is a Tyndall effect. So which of the following will show the Tyndall effect? Option A is salt solution. Option B is milk. Option C is copper sulfate solution. And option D is all of the above. So which of the following option will show Tyndall effect? Alright students, so what is Tyndall effect? Coming back to Tyndall effect, okay? The scattering of beam of visible light by colloidal particles is known as Tyndall effect. So let us see here. salt solution, it is not a colloid, so it will not show Tyndall effect. Copper sulfate solution is not a colloid, so it will not show Tyndall effect. So all of the above cannot be the answer. So for this question, the correct answer is option B, that is milk, because milk is a colloid and colloidal particles show Tyndall effect. So the correct answer here is option B, that is milk. Okay. So here are some of the examples of Tyndall effect. Okay. Here we have in forest, okay, in dark forest, you will see this light rays. This is the Tyndall effect, okay. The small particles present in the atmosphere will scatter the beam of visible light, and that is how we see this. Another example we see here is the cloud. There are particles, okay, colloidal particles present in the cloud which scatter the beam of visible light, and that is how we see structure like this. This is also another example of Tyndall effect, and this is underwater. The water contains small particles, small colloidal particles which scatter the beam of light, and that is why we will see this, okay, this phenomena even underwater. This is also example of Tyndall effect. Another example that we see commonly in our day-to-day life is a room filled with smoke. Okay, when the room is filled with smoke, the light entering the room through small holes or windows, okay, you will see structure like this. That is due to Tyndall effect. Okay, the small particles present in the atmosphere will scatter the beam of visible light. Okay, and that is how we are able to see these rays of light. Okay, and this is known as Tyndall effect. So these are some of the examples of Tyndall effect. Okay. Alright students, so we have here milk. Okay. Another properties of colloid is they do not settle down when left undisturbed. That is, colloid is quite stable. Okay. The milk, even if we left it undisturbed for some time, it will not settle. The milk particles will not settle down at the bottom, but it will remain as it is. So they do not settle when left undisturbed. A colloid is quite stable. Okay. Now students, can you tell me, can we separate, okay, the components of this colloidal solution by filtration? Yes students? No, right? We cannot filter. Okay, so the solute particles cannot be separated easily by filtration method. Okay, so these are some of the properties of colloids or colloidal solution. Now in solution we have two components, that is the solvent and solute. Correct? Solute is the component present in smaller amount or lesser amount, and solvent is the component of solution which is present in larger amount. In colloid we also have two components. There are dispersed medium and dispersed phase. Okay, dispersed medium is similar to solvent and dispersed phase is similar to solute. Okay, so let us see. The component of a colloidal solution are the dispersed phase and the dispersion medium. The solute-like component of the or the dispersed particle in a colloid form the dispersed phase, and the component in which the dispersed phase is suspended is known as the dispersing medium. Okay, so in solution we have solvent and solute. In colloid we have dispersed phase and dispersing medium. Remember this term, okay students? Alright students, we have another question. Please get your rough devices ready. The question is, which of the following is not a component of colloidal solution? I'm giving you 30 seconds for this question. Your time starts now. Which of the following is not a component of colloidal solution? Option A is dispersion. Option B is dispersion media. Option C is dispersed phase. And option D is all of this. So which of the following is not a component of colloidal solution? Alright students, your time is up. Now we have just seen that In colloidal solution, there are two components, namely dispersion medium and dispersed phase. So here we have only two components. Okay, so option A is not the component of colloidal solution. Okay, so here the correct answer will be option A, that is dispersion, because dispersion is not a component of colloidal solution. Very good, students. Activity. Okay, another homework for you, students. Check out the Tyndall effect for the solutions given below and note down whether the solutions show Tyndall effect or not. Okay, so given below are some of the solution. You have to check whether the solutions show Tyndall effect or not. The first we have is shaving cream. The second we have is jelly. The third we have is sugar. And we have soap solution. Okay, so this will be your homework, okay, to check whether the following solutions show Tyndall effect or not. We have one more, that is copper sulfate solution. Now let us see some common examples of colloids. Okay, we have discussed about colloids. Let us see some common examples. There are different types of colloids, okay, depending on their dispersed phase and dispersing medium. So let us see. The first we have here is when the dispersed phase is liquid and dispersing medium is gas. This type of colloid is called aerosol. Some examples are fog, clouds, mist. Okay. The next is when the dispersed phase is solid and dispersing medium is gas. This type of colloids is also called aerosol. Some of the examples include smoke, automobile exhaust. The next we have is if both the dispersed phase and dispersing medium are gas. This type of colloids are called foam. Example is shaving cream. Next we have is if both the dispersed phase and the dispersing medium are liquid. This type of colloid is called emulsion. Some of the example includes milk, face cream. Okay. The next we have is if the dispersed phase is solid and dispersing medium is liquid. This type of colloid is called sol, and some of the examples are milk of magnesia, mud. Okay. The next we have is if the dispersed phase is gas and dispersing medium is solid. This type of aerosol, this type of colloids is called foam. Okay. And some of the example includes foam, rubber, sponge, and pumice. Okay. The next we have is if the dispersed phase is liquid and dispersing medium is solid. This type of colloid is called gel, and some of the example include jelly, cheese, and butter. The next we have is if both the dispersed phase and the solid, if both the dispersed phase and dispersing medium are solid. This type of colloids is called solid sol. Okay, and some of the examples include colored gemstone, milky glass, etc. So these are some of the examples of common examples of colloids. Okay. All right, students. So in today's class, okay, we have discussed about suspension and colloids. Yes, students. At first, we have discussed about concentration, how to calculate the concentration of the solution by using some formula. We can calculate the mass percentage by using the formula concentration of solution is equal to mass of solute by mass of solution into 100. We can calculate the volume percentage of solution by using the formula concentration of solution is equal to volume of solute by volume of solution into 100. So by using this numerical relation, okay, by using this formula, we can calculate the mass percentage and volume percentage of the concentration of the solution. Then we have discussed about suspension. So what is suspension? Okay, a suspension is a heterogeneous mixture in which the solute particles are suspended. Okay, in which the solute particles are suspended in the solution. Okay, or in a medium. In suspension, the solute particles does not dissolve, but it is suspended in the medium. Okay. Now we have discussed the properties of suspension. Yes, students, can you remember what are the properties of suspension? The first is a suspension is a heterogeneous mixture. That is the first property of suspension. Then we have the particles of suspension can be seen with our naked eyes. Yes, students, particles of suspension is larger than 100 nanometer and it can be seen with our naked eyes. The next property is the particles of suspension can scatter beam of light passing through it and make its path visible. Okay. The next property we have is the solute particles of suspension settle down at the bottom when left undisturbed. So from here we can know that suspensions are unstable. Okay. Now we have also discussed that the particles or the components of suspension can be separated by filtration method, and the solid substance that is left on the filter paper is called residue, and the clear liquid obtained is called filtrate. Okay, now some of the examples of suspension include, yes students, chalk powder in water, that is one. Another example is flour in water. Another example is sand in water. And another example can be soil in water. Okay, so these are some of the examples of suspension. You can add your own examples. Okay. Now, the next we discuss is colloids or colloidal solution. Yes, students, we have seen that colloids, although they appear to be homogeneous, actually they are heterogeneous mixture. Okay, the particles of a colloid are uniformly spread through the solution. Okay, throughout the solution, due to the relatively small size. Okay, due to the relatively small size of the particles of colloids, they appear to be homogeneous, but actually they are heterogeneous mixture. Okay, so let us see the properties. Let us quickly recall the properties of colloids. The first property of colloids we have discussed is that colloids or colloidal solution are heterogeneous mixture. Okay, the particles the particles of the colloidal solutions are relatively smaller than the particles of suspension. Okay, and that is why we cannot see the particles of colloidal solution with our naked eyes. That is the second property. The third property that we discuss is colloidal particles. Okay, they are relatively small, so we cannot see with our naked eyes, but they are big enough to scatter a beam of light passing through it and make its path visible. Okay, so the particles of colloids can scatter a beam of light passing through it and make its path visible. Okay, now we have also seen that Tyndall effect. Yes, what is Tyndall effect? The scattering of beam of visible light, okay, by the colloidal particles is called Tyndall effect. So this is what Tyndall effect is. We have also seen some examples of Tyndall effect. Yes, when you go to forest, okay, full of trees, okay, you will see some rays of light. That is example of Tyndall effect. We can also see Tyndall effect when light passes through the cloud and also in a room filled with smoke. So this is what Tyndall effect is, and these are some of the examples of Tyndall effect. The next property of colloids we have seen is that they do not settle down. The particles of the colloidal solution does not settle down even if left undisturbed. So from here we can say that colloidal solutions are quite stable. Okay, and like the solutions have two components, that is solute and solvent, the colloidal solution also have two components known as the dispersed phase and dispersing medium. The dispersed phase, okay, the dispersed phase is the solute-like component and the dispersion medium is the solvent-like component. Now depending on the dispersed phase and dispersion medium, we have here some common examples of colloids. Okay, so these are some of the common examples of colloids. Now there are different types of colloids depending on the state of the dispersed phase and dispersed medium given in this list. Okay, so you try to remember the different types of colloids and the state, okay, in the state of the dispersed phase and dispersing medium. Alright students, so this is it for today's class. Okay, we have one last question for today. Please get your rough devices ready and respond to this question. Okay. The question is, how do you feel about today's class? Okay. Option A is happy. Option B is quite good. Option C is satisfactory. And option D is confused. So I'm giving you 25 seconds for this question. Your time starts now. Yes, students, how do you feel about today's class? Option A is happy. Option B is quite good. Option C is satisfactory. And option D is confused. Alright students, your time is up. Thank you so much for your response. I hope you are clear with what we have discussed today. I will see you again in our next class, and thank you for joining today's class. Take care everyone. I will see you again in our next class, and have a nice day.